Hi everyone, Radical Tutor here explaining. In this video, we are going to look at integration, and the question we are doing today is to integrate the integral of dx over 9 minus x squared. Now, if you are given such a question, you need to know that it is coming from the three forms of integration. So the three forms of integration are those ones where you are given the integral of, something where a is starting and it is squared. There is a minus, x is put to the other side of the equation like that. So if you have such a case, meaning that you need to start by rewriting this 9 in form of where you have an a and a square. So by doing so, you are going to have the integral of dx over 3 squared minus x squared, like that. Then you need to start by replacing. Whenever you find that a is starting and there is a minus, x is to the other side of the equation, then always start by letting x to be equal to a sine theta. So a sine theta. But in this case, our a, we know that it is a 3 here. So if it's a 3, instead of us putting a, we are going to put a 3 there. So we put a 3. We are going to put a 3 there, which is going to be like this. So we are going to put a 3. We put a 3 sine theta. Then after getting 3 sine theta, get dx. So your dx is going to be differentiating there. The 3 is constant. Differentiating a sine theta is a cos theta. Then you add, so here we are getting dx, not d theta. So dx is equal to 3 cos theta. Then you add d theta like that. Right. Now from there, replace these assumptions or parameters in the question. So by replacing them in the question, you are going to have the integral of dx. We are putting 3 cos theta d theta over, we have the 3 squared down, minus where there is x, we are putting a 3 sine theta like that. Now, if you have such a case, what you're supposed to do is remember where there is x here, the x is squared, meaning that even as you are replacing on the x, this should be a square there. Now, by doing so, you are going to have, we are going to have the integral of 3 cos theta d theta on top over the 3 squared, we can say it's 9, minus 3 squared also is 9, sine theta squared is a sine squared theta. Now, after you've done that, what you can simply do is you are going to say we have the integral of 3 cos theta d theta over the 9 here is common, so you can factor it out, and then you have 1 minus sine squared theta. Now, it must interest you to note that when you have 1 minus sine squared theta, according to the Pythagorean identities, you know that if you have a sine squared theta plus cos squared theta, this is equal to 1. So if you are to make cos squared theta a subject, you are going to have a cos squared theta is equal to 1 minus sine squared theta. So here, instead of us maintaining the 1 minus sine squared theta, we can simply replace it with the cos squared theta. That's what we are going to do. So by doing so, we are going to have the integral of 3 cos theta d theta over, we have the 9 outside, and then 1 minus sine squared theta, we are saying we are putting a cos squared theta. Now, we can say 3 into 3 is 1, 3 into 9 is a 3. So 1 over 3 will be a constant that can come outside the integral like that. 1 over 3, so I've cancelled that, we have a 3 there. 1 over 3 is a constant. I'm going to remain with a cos theta on top, d theta, over, down we have 2 cos thetas that we can write as cos theta times cos theta. Then from here, you can cancel 1 cos theta and 1 cos theta, meaning you are going to remain with 1 over 3 integral of, on top we've remained with the 1 over a cos theta d theta. Now after that, that's when now you can change this 1 over cos theta to another identity or another trigonometric identity, which is 1 over 3. 1 over cos theta is the same as a sec theta. So we are integrating now the sec theta d theta like that. Now integrating the sec theta is just like a standard form of these are standard integrals that you can know for trigonometry or trigonometric ratios. So in this case, we're going to say 1 over 3 integrating the sec theta is going to give us natural log. So whenever you integrate a sec theta, the answer that you get is simply just the natural log, so you get the natural log of sec theta plus c tan theta, like that, then plus c. So this is the final answer that you are going to get. But please, whenever you are integrating using this type of integration or substitution, never should you leave your answer here. Why? Because the question was given in terms of x, and you shouldn't leave your answer in terms of theta, because our answer, as you can see, it is in terms of theta. So we can first change the theta to x. That's when we can say that we are done. So how can you change it? Go to the assumption you made. The assumption you made here was x is equal to 3 sine theta. So from there, just make theta the subject so that you replace it in your answer. So by doing so, we are going to say that we have x was equal to 3 sine theta. So make theta a subject by dividing first by 3 by 3, meaning that our sine theta is equal to x over 3. Then make theta a subject. By making theta a subject, you're going to have theta is equal to sine inverse of x over 3. That means where there is theta now in the question, or rather in the answer that you found here, replace by sine inverse of x over 3. So by doing so, we shall have our final answer, which is 1 over 3 natural log of sec theta. Now we are putting sine inverse, so we are putting now sine inverse of x over 3, and then plus tan theta, we are putting the same, which is sine inverse of x over 3, and then at the end plus c. So meaning that this becomes your final answer if we are to integrate this type of a question under trigonometric substitution. Thank you so much for watching this video. Kindly follow my page after watching, so that at least we can have a very big number following the page. And also don't forget to invite other people to follow the page. If you're on YouTube, kindly subscribe to my YouTube channel as well, so that we can grow the numbers together. See you next time.